Welcome viewers. In this lesson, we want to consider arithmetic progression. In our previous lesson, I gave the definition of sequence and series. I gave several examples and how each terms are generated. From then, I gave two types of a sequence. I gave the linear sequence, which is a arithmetic progression, and a geometric progression, which is also known as the exponential sequence. So in this lesson, we want to focus on arithmetic progression. So just to remind us again, arithmetic progression or linear sequence are sequences that are generated by addition of positive or negative number. These sequences are generated by addition of positive or negative number, and sometimes it may be expression, depends on how the question is given. Now let's consider this example. Suppose we are given this. Let's consider this sequence. We have 3, -2, -7, -12, -17. Now, looking at this sequence, the first number is what we call a first term. So here is the first term of the sequence. And what do you observe that is being added here? Are we adding a positive number or a negative number? So definitely it's negative number because this is decreasing. Most time when a negative number is being added, the sequence will be decreasing. When positive number is being added, the sequence will be increasing. So from our observation, this is decreasing. Definitely a number is being taken from each term. And what is that number? -2 minus 3, that is -5. -7 minus -2, that is -5. It means the common difference here, you can see this, the difference between first and the second term is the same as the difference between second term and third term. And that is how it continues. So 3 is first time, so that is your first time, T1. Second time, T2, T3, T4, T5. And when you continue to certain extent, you get to Tn. And at some point, it tends to, when you have, this is a finite, this is infinite sequence. So because of this, this is tending to negative infinity. So it's an infinite sequence. It has no limit. So now, but each term is represented with what? T1, T2, T2, and as you continue in that way. Now, to generate so now here is our first term. This first term is known as T1. To generate the common difference now, we have to take the first term from the second term. So it means T2 minus T1. And also, to generate the second common difference again, we can say T2 minus T3. So that's the same thing as T3 minus T2, T3 minus T2. Or you say T4 minus T3, which is a T4 minus T3. So because of this, we can just generate a formula for common difference. And that is your Tn minus Tn minus 1. So this is the common difference. So our common difference is represented with letter D, and this is formula for common difference. So second minus first, or third minus second. And that is how it follows. Now, here's our first term, T1. T1 is the first term, and we represent that with letter A. And generally, the formula for linear sequence of arithmetic progression is given as a Tn equals A plus n minus 1 D. Here is the formula for the nth term of a linear sequence or arithmetic progression. Our Tn is the nth term. Nth, that's the position. Nth term. So that's your Tn. Your A is what we call what? First term. Our N is just the number of terms. N equals to number of terms. And our D is the common difference. Our D is known as what? Common difference. So once you add the common difference to first term, you get your second term. Add the second, you get the third. As you continue, you get each successive terms. So this is just all we need to the basic knowledge we need to have on this arithmetic progression. Now let's consider example. Now let's use this as example. Now suppose the question says you are given this sequence. The question says find the 20th term. The question says find what? Find the 20th term of this sequence. So what if the question says find the 20th term? You don't need to stress yourself and continue adding. What if the question says find the 2000th term? So you know that will be very difficult. So but what will make it easier is this formula. What you only need, you put in each value, the value of each terms. Yeah. Now the question says find the 20th term. It means our t. So now what's our Tn? That is T20. So now our first term in this question. So the first term here, the first number. So that is your A. So T20th, we don't know. Our A equals to 3. What's the common difference? You know, I said earlier, you said second minus first, or you say third minus second, and that is how you continue. So now when we take any of this, so let's say we have our common difference D equals to -2 minus, minus 3. -2 minus 3 equals to -5. Meaning our common difference here is -5. Then n, question says 20th time, it means our n equals to 20. We know the value of A, value of n, value of D. What is needed again? You just need to put in the values. So our T20th equals to A. You know our A is what? 3. So that is 3 plus n minus 1. N is 20. So that's 20 minus 1. Our D, which is common difference, -5. So -5. So you don't need to write. You don't write it this way, because we just write -5. That's another interpretation. So but you put it in bracket to show that you want to multiply. Now let's simplify this further. So this equals to 3 plus 20 minus 1, that is 19. So 19 multiplied by -5. So when you multiply 19 by -5, that is just -95. So here we have, you know, this is 3 plus -95. Or in other way, just write 3 minus 95, because plus times minus is what? Is minus. So now the final result, T20 equals to 3 minus 95. And that is -92. So here is the first example. We try to explain what linear sequence is with example and how each of these the meaning of each terms in the formula and the uses of a formula. So now we The next class will take more examples on how to make use of this formula.